series Programming in C. In this module, we are going to learn about pointers, and also we are going to learn in detail about how pointers work in the basis of compilers. So, introduction to C pointers, dereferencing pointers in C, different step of pointer program and special types of pointers, address operator ampersand. This is what we are going to see on this module. Let us learn what is pointer. A pointer variable in C that stores the memory address of another variable. This is actually an important and interesting concept of C language, because generally we will try to store a value onto a variable. The value can be of any type, maybe an integer, a floating point value or a character. But then a variable allows us to store the address of another variable itself. This is actually a significant concept of pointers, so that it allows us to have access to the memory directly. So, what it means, whatever the memory does, we will be able to get the knowledge of accessing the memory directly through pointer variables, right. How do we declare the pointer variable? It is very simple, that we need to mention the data type, asterisk symbol and the pointer name. Asterisk is a special symbol for representing pointers, or we are giving the indication, or we are giving the information to the compiler that it is a pointer type variable. The data type indicates the type of variable the pointer can point to. It means that in address, whatever the value we are going to store, that data type would be the data type of the pointer variable. Say for instance, when I am trying to store an integer value onto a particular memory location, then my pointer variable's data type would also be integer. So, this way of storing int asterisk pointer PTR is a pointer variable, declares a pointer to an integer. Okay. It is, this int is not the data type of the pointer, because a pointer is going to store the address always, whatever irrespective of the data type, but the data type which we specify on the declaration of pointer is going to be the value which the pointer is going to point to. Accessing the pointer directly will just give us the address that is stored in the pointer. To get the value at the address stored in the pointer variable, we use asterisk operator, which is called dereferencing operator in C. I again repeat, while accessing the pointer, we need to declare the pointer variable, right. But to access the value which is stored in the pointer variable, say for example, in this case if it is int asterisk pointer, there may be an integer value in the location. For accessing that integer value, we will again use operator, asterisk operator, which is called now dereferencing operator, because we are trying to represent, or we are trying to access a value stored in a particular address, hence it is called dereferencing operator. Now, you should have noticed that we are using the asterisk for two different purposes in pointers. One is to declare the pointer variable, the other is to access the value that is stored in a particular location of a pointer. So, the asterisk operator will be used in two different ways, right. So, let us take a simple example. In this example, we are having an integer type variable which has a value 10. I am now declaring a pointer variable also of integer type, and I am trying to store the address of the normal variable var, which we have already declared. Now, using this pointer variable, I am trying to access the value stored in the variable var. Okay. Let us assume this way, we have a set of memory locations in memory which will be represented using address. Okay. So, as it is given, so I assume that 5308 5310 is going to be the address. Okay. What I do now, I am declaring a variable var with value 10. Okay. So, what happens for this particular variable VAR, there would be a address assigned. So, let us assume that 5310 is the address assumed for the variable VAR. Now, I am trying to declare a pointer variable PTR. I am trying to declare a pointer variable. The pointer variable points to the address of VAR. So, the address of VAR is going to be 5310. So, 5310 will be the content of the pointer variable, right. So, when I am now trying to access the pointer variable, I will be getting the address of the variable VAR. So, that is what here we are doing. We are printing the value of PTR, which is actually the address. So, the output will be the address of VAR, right. Supposing if we want to know the value stored in the particular location or in the particular address, then we are again supposed to use the symbol asterisk. So, let us assume the way that value VAR variable is stored with the value 10 and its address is represented in the hexadecimal notation. So, if it is hexadecimal value, it starts with 0x, right. Okay. Now, this is what is the address of variable VAR, which is actually stored in PTR, right. But the address of the pointer variable will be a different address, right. So, if we are trying to display the address of the pointer, the address of variable, accordingly you will be able to get the address displayed, right. We will see the way how the pointer can be initialized and how to use it in our program. The pointer is initialized by assigning it the address of a variable using the address operator. So, we need to use the special symbol ampersand to assign the address of one variable to the pointer variable, right. We can also initialize a pointer variable with null value. It means that it does not point to any variable. Okay. So, simply we can make use of the declaration this way. We can just make use of the keyword null can be assigned to a pointer variable. Now, dereferencing a pointer, we have to first dereference the pointer to access the value present in a particular memory address. So, we are going to use a dereferencing operator asterisk for doing so, right. The same program we will take, we are having the same variable declared and here the address of VAR is stored into the pointer variable PTR, right. Now, instead of in the previous case what we have displayed the value of PTR, value of PTR is going to be the address, but if I want to display the value which the pointer is pointing to, okay, then we are supposed to use asterisk PTR, okay. And the format string will also vary accordingly. Here you can see that the format string is %p for address and %d for the value stored in the particular address. Now, the output is going to be the value which is assigned by the to the variable VAR. So, here we are using this asterisk operator to dereference the value of the pointer. So, here we can call that as a dereferencing operator. And we need to know few things about pointers. What about the size of pointer? The size of a pointer in C depends on the architecture of the machine. It is not dependent on the data type it points to. Okay. Supposing if we are declaring int asterisk PTR, int is a data type which the pointer PTR1 points to. Char is a data type which the pointer PTR2 points to. Okay. But if you look into the size of these two pointers, the size of these two pointers is not going to be integer size and character size. It is going to be the size of the address, which is always going to be the same, which is not dependent on the data type using which the pointer is declared. Okay. So, this size of the pointer depends on the architecture of the system. Okay. If it is going to be a 32-bit system, all pointers will occupy 4 bytes. If it is going to be a 64-bit system, all the pointers will occupy 8 bytes. So, that is how the size of the pointer is being identified, and it is not dependent on the data type. The size remains constant regardless of the data type. Whatever be the data type we use for defining the pointer, irrespective of that, the size will be the same, and the size of the architecture, whatever the size which we use for the compiler, right. There are some special types of pointers. Null pointer. The null pointers are those pointers that do not point to any memory location. It means that generally for defining a pointer variable, we will be using the ampersand operator to point to a particular location of a variable. So, here even though if you do not want to point to a particular memory location, we can define the pointer and assign the null value to it, then it becomes a null pointer, right. So, a pointer of any type can be assigned null value. So, this allows us to check whether the pointer is pointing to any valid memory location by checking if it is equal to null or not. So, just for verifying that whether a particular memory location points to a valid value or not, we will be able to use the null pointer. So, null pointer allows us to verify whether the particular pointer is pointing to a valid memory location. And void pointer, the opposite of null pointer is void pointer. Void pointer in C are the pointers of type void. It means that they do not have any associated data type. There is no data type need to be there for pointers. So, they are also called generic pointers, as they can point to any type and can be typecasted to any type. Because sometimes we may not be able to judge what would be the data type or what would be the type of data which the particular memory location has. So, in those cases we can just declare it as a void pointer, and we can make the void pointer to point to any type of data which is there in that memory location. So, this is a way that the void pointers can be defined. The next category is wild pointer. The wild pointers are pointers that have not been initialized with some value. Okay. So, it means that there will be a pointer variable, but that is not being given any value, or that is not being point to any particular address. Okay. So, this is called wild pointer. So, the way that wild pointer can be defined is this. Okay. Here it is not even pointing to null. If values are updated using wild pointers, they could cause data abort or data corruption. Okay. So, we have to be very careful on using or applying wild pointers in case if we are going to use it in programs. Then the address operator ampersand, right. So, it is actually a special operator in C, which is denoted by the symbol ampersand. So, this operator returns a number which is the address of its operand. We can use this operator for any type of variables. It can be of integer, character, array, string, functions, whatever it be. So, generally what we will do, we will use the ampersand operator to denote the address of a particular variable. Say for instance, A is a variable whose address is 1000. So, we can say that ampersand A points to 1000, ampersand Q points to 1004. Ampersand M points to 1012. So, this is a way that the ampersand operator will allow us to store the address of a particular location. So, how we will be able to use it in our program? You can just make use of an integer type variable and printing the address. Simply I do not want to go for using pointers, or I do not want to store its address, I just want to print the address of a particular variable. It is enough, you can use it as ampersand x, but see to that you need to use the format string to be %p, because the address will be in hexadecimal format. So, for allowing hexadecimal form, we are supposed to use the %p as the format specifier. Okay. Now, we know now how to use the ampersand operator to store the address of a variable. Now, after storing the address, how to access the particular address using pointers. Okay, so that we are supposed to learn, right. So, the same way we are defining an integer variable x, right. Now, we are trying to access the address of x using ampersand x and then use the format specifier %p. So, this actually will print the address in the hexadecimal format, right. So, we will take a small example of using pointers. I declare an integer variable and assigning a value 1 to it. I also declare the same data type int with a pointer, and I am assigning the next step is to assign the address of variable x to the pointer variable. The next step will be accessing its value. Now, how to access the value stored in x? It is by same way using the asterisk operator. So, here we are using asterisk operator in two places. One will be for declaring the pointer variable, the other is for accessing the value stored in the pointer. So, step 1 is define the integer variable, assign some value to it. Second step is declare the pointer variable. Third step is assign the address of the variable to the pointer variable. The fourth step is accessing the value of the variable using the pointer, right. So, here we can see that the two operators asterisk and ampersand becomes very significant in using and dereferencing the pointer. And we can also see that some standard functions also requires the address of variable, say for example scanf. Okay. Scanf function is used to read some value from the keyboard, right, and it has to, the value which is reading from the keyboard has to be stored in some memory location. So, at that time it needs to know what is the memory location to which the particular value can be stored. So, in order to know that, we are using ampersand operator even in some standard functions like scanf. Then where actually we will be using the pointers in a deeper level of compiler usage, dynamic memory allocation. Okay. So, this is one important concept where using pointers we will be allocating the memory. So, what is memory allocation? Programs sometimes do not know in advance how much memory they need. Pointers allow memory to be requested during runtime using functions like malloc or cloc in C programming. For example, when creating a list of users where the number of users is unknown, pointers let them program allocate exactly the memory needed. Without pointers, memory would be rigid and we will be wasting the memory. Efficient array and string handling. Again, if we are not able to fix up the size of the array, and if you are able to know and fix up the size of the array only on runtime, only while running the program, only when executing the program, at that time we can make use of pointers to assign the memory addresses dynamically. Okay. And building complex data structures. As we have already seen, the self-referential structures may need pointers to refer to the same structures. So, the data structures which are complex like linked list, trees, graphs, stack, queues, which requires self-referential concept and pointers to refer to the next node or to refer to the memory link as a chain. So, those things, those places we may require the pointers. We will make use of the power of pointers in various algorithms and systems. Actually, because of pointers only we will be able to be successful on building up various data structures in C for serving various applications. Passing arguments by reference to functions. This is one interesting and important thing to learn. Actually, call by reference, using call by reference we are trying to make or we are trying to copy the address of one location or one variable, and we are passing the address as a reference to the function. Okay. So, at the time of passing the address, we will be using the pointer variables to be passed as arguments, and that will take the address of that particular variable as an argument, so that we will be able to have direct access to the memory locations. An interaction with hardware. So, this is very important thing, because of the usage of pointers only, the system programming, embedded systems and operating systems have grown in a very efficient way, and whatever the concepts or whatever the advantages of the languages like C++ and other higher level languages we use, pointers really help us in interacting with the hardware. Supposing if I am going to come up with a new hardware and if I want to talk to that hardware through my program, that could only be possible with the help of pointers, because pointers talk to the memory locations directly without having any intermediary support of variables. Right. So, summarizing on the way of addressing a variable or address pointers or operators. So, the address which we are returning using ampersand operator will be an hexadecimal value. So, that will be representing to the memory location, and every variable in C has a unique memory address. Accessing the address of a variable is useful when you need to pass variables address to functions, work with pointers or perform memory related operations. On summarizing this particular module or session, I will give you one simple example, that there will be a symbol table. There will be a symbol table in all the programs which we use. The symbol table will be having a mapping of the variables of the program with its memory location. Supposing if I have a variable named A and a variable named B. Okay. For the symbol table, the variable A will be assigned with its value of address and B will be given another address memory location. Okay. In the memory location, say 5308 will be storing the value of A, value of A, and 5310 will be storing the value of B, Supposing when I am trying to print the value of A using the printf statement, so what happens at the compiler level is that when it encounters this symbol, immediately it searches the symbol A in the symbol table and it retrieves the address 5308 associated with A, and then it is able to fetch the value from that location and it displays the value of A. Right. Supposing when I am trying to print the value of B the same way, LF, the same way it locates the address and then it finds a value. Supposing when I am declaring a pointer variable int asterisk ptr equal to ampersand A. So, what happens? The ptr will be a variable which has the access to the pointer variable A. Actually, ptr will be in different location, okay, but the value which is there in that ptr will be the value of A. Value of A is going to be the address 5308, right. Now, if I am going to print the value of ptr percentage %d comma asterisk ptr, if I am trying to access the value of asterisk ptr, we will be directly able to get the address of A. So, in case if I want to get the value stored in that location, I can directly go to that 5308 location, I can get it. So, what happens actually here, instead of having two fetch statements, it is limited to now using single fetch statement using pointers. Supposing if I have a program which is going to fetch the value of a variable 100 times. So, if it is going to be a normal variable, it takes 200 fetch time, whereas when I am using the pointer, it is reduced to half. With only 100 fetch timings, we will be able to execute the program. So, using pointers, the program executional time will also be reduced, so that it is very efficient to use pointers in case of C programming, because C programming allows to access the memory directly using pointers. So, thank you for listening to this session and learning about pointers.